Welcome to the new episode of the Devoteam Cloud Lounge. Continuing our migration series, and from what we saw in our first episode, I'm talking about how customers are migrating their applications to the cloud. We talk about an application which was developed by Devoteam Germany for a large organization from Europe who believes in creating expensive and luxurious products for its end customers. In this case, we're talking about an application that was running on-premise in Kubernetes clusters and was migrated by our team on the screen that we have Robert today and to AWS using Serverless. Welcome, Robert, to Cloud Lounge today.
Yeah, hey, Robert. Thank you for the invitation.
Thank you, Robert. Pleasure having you. I know you've done some amazing work with customers in Germany and outside across EMEA. In this kind of a case, I believe one of the reasons that the customer wanted to move away from on-premise was to have a highly scalable solution for their end customers in a highly availability manner, and also trying to reduce the costs for it. Now, what can you tell us about the application, what the services were, what kind of projects and services did you see for the customers during the assessment process?
Yeah, so let me introduce the system a little bit.
Please.
So basically, we have one core service, which is the heart of the system. It consists of an HTTP service, which has a very complex business logic, and it really needs to be running 24/7 and doesn't allow any downtimes and failures. So really an important service. Second, we have the sync service, which is synchronizing data from an external data source to our local database. And it's also quite important because the database is the base for all of the complete business logic. Additionally, we have some simulation services for testing, for simulating campaigns. And also we have a front-end application, which is used by the customer directly for configuring purposes, for log visualization, also for testing and so on. And lastly, well, this is not really an application component, but it's the database itself. And in our case, we have a Postgres database, and it's really the most critical part because without database, our system does not work anymore.
So was the customer using a PostgreSQL server in on-premise for this setup?
Yes. So an own created Postgres database on their servers. Yeah.
Understood. So thanks for that. That was on the application side, but from the infrastructure side of things, what all things that you assess in the discovery and assessment phase for the customer?
Yeah. So the infrastructure looked already quite good. It was also running for a few years in this mode. So it looked like all the applications were running as Docker containers in a Kubernetes cluster, and also there was a lot of redundancy. So, for example, for the integration environment and for the production environment, we had two complete same clusters just for high availability purposes. And as you can imagine, this was not very cheap. And yeah, also for the CI/CD part, we were sharing a Jenkins server with other teams and other projects. Also, there was a Harbor registry for storing Docker images, which was also shared by other teams and was provided by the customer. And yeah, as already mentioned, the database cluster was also running on dedicated VMs, and was set up and operated by us. And yeah, so this was really one of the pain points for us in the past.
Oh, I can imagine. Thanks for that, Robert. I think the infra looks quite good for an on-premise setup. So if you were doing something like this 10 years back, this was pretty good in that sense. But as the advent of cloud has come up, people are more moving to cloud native services, microservices, and even containers, for example, on the cloud. And Amazon has two services like EKS and ECS and Fargate as well in terms of how to get there. But some of the work that I did, research that I was doing for this project, we realized that using some of the issues with scaling, the customer's shared resources were being used, and the costs for running all of this on-premise was quite high. I think from the numbers that you shared with me, there has been a 1/5 of the cost of what the customer was actually spending on premise versus on AWS. I think the numbers look somewhere between 10,000 on premise per month, dollars per month, and on AWS it is approximately 2,000. That's a really good cost saving for the customer in there.
Yeah,
Okay.
definitely.
Yeah. Now, again, from the work that we have been doing for customers, modernization via the process of migration is a great approach for customers to look at. And this is the kind of project that we'll want to look at. Now, in terms of the services that you used in AWS, what are the kind of problems that the customer had at the start, and how did we actually solve them? Could you walk us through something on those lines, please?
Yeah, for sure. So as already mentioned, we had a lot of redundancy and high cost regarding the clusters, and also a lot of these applications were just running in idle mode because they were rarely used. For example, the simulation services and the front end, and this resulted in really high cost and unused resources. And in this case, Lambda solved really all of these pain points. So Lambda is a serverless function, which is like function as a service in the cloud, and it's running completely serverless without dedicated servers. And yeah, I was also mentioning the CI/CD part. We had possibly long builds and interrupted builds because of other teams, and this was actually eliminated by the code pipeline, AWS code pipeline, which was dedicated to us and is also running serverless. And yeah, also the Docker registry. We had a lot of connection problems, and now with Lambda we don't need a Docker registry anymore, actually. And yeah, the most pain points, as already mentioned, were actually the database, because the database storage was not scaling automatically, and we really ran into problems sometimes. And also the patching of the database servers, of the database engine, was a real pain point, which was causing downtime sometimes. And also the setup and the maintenance of the database itself was really not nice. And all of these points were resolved by using Amazon RDS.
Nice. I think RDS has gained a lot of popularity over the years. Back in the day when customers had to patch their database services, it was a nightmare for a lot of database administrators to not touch a database server. I think I was reading something this morning and where they used to say, do not touch a running system. But I believe that you must touch a running system as well, because you need to patch it, but do it in the right manner. Use more managed services like Amazon RDS, or in a repeatable manner as such, you could do that. What are the kind of other services? Would you like to walk us through how the AWS setup looked like then?
Yeah, sure. So in this case, I just give you a brief high-level overview of our architecture. Please. So of course we have used a lot more AWS services like VPC and security groups and IAM roles, but this is out of scope here. So this is, let's say, the high-level architecture. And you can see on the top left corner, we have the entry point for the clients, which is firstly secured by a web application firewall for security purposes. And yeah, in the light blue path, you can see the front-end path, which is represented by a CloudFront distribution, by an ALB and S3. And the other path is going through an API gateway and is calling the core service, which is our main service, as already mentioned. And and also on the bottom, you can see that we have also some event-driven architecture where we trigger some Lambda functions based on an event bridge event and read messages from message queue and write back to the message queue. So yeah, as you can see, the whole backend code is implemented and deployed as Lambda functions. So we have actually not one server running on our side.
That's amazing. I think I have a question for you. In this case, you chose to use serverless technologies and Lambda function. Could you have also used any other microservices or containers services? Would you have done a container to container migration?
Definitely, for sure. We were considering that. And I guess it would also have been easier to migrate because it was already running as Docker image. But after some, let's say, some a short investigation, we saw that the Lambda approach was the perfect fit for our use case regarding the cost and the high availability factor.
Yeah, I think that's really important why
us.
you're doing this, and having the intention of highly available and a cost-effective solution. I don't think anything gets better than that. I think customer has seen some of the benefits in here, and in terms of how they are running their infrastructure. So some of the AWS services that you mentioned about, I think they are on the screen. What you used for this customer, we've spoken about this quite length, and all of these services are AWS native services. There is nothing which is a third party. Like you could have used GitLab or GitHub, something for CI/CD, but you continue to use code pipeline. So that is quite brilliant. Could you tell us a little bit about the kind of monitoring and alarming, those kind of things that you set up for this project?
Yeah, sure. So regarding the alarms, for example, we also set up like alarms with CloudWatch and SNS to send email notifications in case of errors, in case of unexpected behavior. And yeah, all of this is also done serverless. So you don't need to provide any servers or any listeners, whatever. You just configure your alarms and you're ready to go, which is really amazing.
It is. I agree. And am I correct that your team did the entire infrastructure build and the backend development of the application as well? Because I'm guessing there would have been some changes to the application code to allow it to work with Lambda. Was that also done by your team?
Exactly. So this was our full responsibility. And actually, there was not a lot to do, but yeah, you need to adapt your code a little bit to work with Lambda. But this was let's say, a really easy refactor.
Oh, this is brilliant. I think one of the things customers do look for when you talk to them about a re-platform, a re-architect, is that we don't have access to the code developers. We don't have access to the people who wrote the code. We don't know what exists. And going back to the line, why disturb something when it is running? But when you are talking about innovation and modernization of your infrastructure, then you need to touch something which is even running, because it's not fit for future, or it's not fit for a business driver in that sense, I believe. A question for you: do you know was there a customer involvement? Did you use customers' help to understand the application, or was the majority of work done by by our team itself?
Yes, the customer, of course, needs to support us understanding the business logic itself. But regarding the infrastructure, we came actually up with the architecture approach, and then
perfect. Good to hear that. I think some of the achievements are on the screen. There has been a lot of debate internally, and a big success story for this large enterprise from Germany, and a customer who is such a end user in a kind of a B2C model. And some of the achievements that we see on the screen, the customer had more highly available infrastructure. The cost reduction was approximately 80% down, and we saw the kind of cost for Lambda was approximately $20 per month. Imagine the costs coming down there. Scalability, Lambda does provide 1,000 concurrent connection executions. There has been a database storage. The database performance with RDS increased as well. And because of the fact that we were using more managed services, there was not things for us to manage, not to patch. AWS did it on its own. And sustainability, because a core theme of anything that we do is using sustainable IT on-premise versus AWS. This is a far more sustainable solution. And I think we saw 95% powered by renewable energy in 2021. Again, very good achievements in there. Thank you, Robert, for an amazing piece of work. I really hope that we are able to name the customer one day, and folks can understand. But then in case you'd like to reach out to us, not asking the name of the customer, but then we can talk you through a little bit of demo around it. So how customers can get started with this, we've got in Devoteam has a migrate to modernize offering. We were AWS's migration partner of the year 2021, and a lot of work is alluded to the fact what the kind of work Robert and the rest of the team in France, Germany, Belgium, Italy, and in the UK are doing. We have a migrate to modernize offering wherein we do a workshop with your teams, give you a report at the end of it, giving an explanation of what is the right path for you to move to AWS. The migration plan and the cloud strategy are aligned and taken into consideration when we write this report. So it's not a report about what we think is right to do. It aligns with your business drivers and goals. On that note, thank you so much, Robert. Thank you for joining us from a cold day in Germany. UK is also cold today, so not much of a difference. But I hope to be having you more on the Cloud Lounge very soon. And we look forward to having a public case study with this someday.
Yeah, thank you for having me here. It was a nice session.
Thank you so much. Thank you so much, Robert. Goodbye.